Welcome to our lesson on designing racetracks using trigonometry. Today we'll learn how to use mathematical principles to create safe and exciting racing circuits. Let's start with the basic elements of a racetrack. The first element is the straightaway, where cars can reach maximum speed. The second key element is the curve or turn, which requires careful design to maintain both speed and safety. When designing a curve, we need to consider three key factors: the radius of the turn, the angle of the turn, and the banking angle. Let's focus on calculating the proper radius for a turn. The minimum radius depends on the maximum speed and the coefficient of friction given by the formula. R equals V superscript 2 slash G asterisk mu, where V is velocity, G is gravity, and mu is the coefficient of friction. Let's solve an example problem. If a car is traveling at 100 kilometers per hour, or about 28 meters per second, and the track has a coefficient of friction of 0.8, what should be the minimum radius of the turn? Let's plug these values into our formula. R equals 28, superscript 2 slash 9.8 by 0.8. The minimum radius should be approximately 100 meters. For safety, we typically increase the calculated minimum radius by a factor of 1.5 to 2.0. In this case, we would design the turn with a radius of 150 to 200 meters to ensure safe racing conditions. By using these trigonometric principles and safety factors, we can design racetracks that provide both excitement for the drivers and spectators while maintaining the highest safety standards.